In the last little video, which was the third in this series of lecture notes on production costs, we derived the following graph, which showed the relationship between fixed costs, variable costs, and total costs. Notice that variable costs, the variable cost curve, was a compound curve. First, it's rising at a decreasing rate, illustrating diminishing marginal costs. Then it starts rising at an increasing rate, showing increasing marginal costs. Marginal costs are diminishing here because marginal product is rising, and marginal product is rising because of specialization. Here, marginal costs are rising because marginal product is diminishing. Marginal product is diminishing because of the law of diminishing marginal returns, or as the book calls it, law of diminishing returns, which I guess is fine. As I mentioned last time, that these are not precisely the curves we are going to be using. The curves that we're going to be using in our analysis is going to be derived from the set of curves. The curves that we're going to be using are the average total cost curve, the average variable cost curve, and the average fixed cost curve. This actually should be an F, not a V. And the marginal cost curve. Let's first look at the marginal cost curve to see what that looks like. As you already know, quantity, $. The variable cost curve is going to look like this, rising at first at a decreasing rate and then starts rising at an increasing rate. That is the variable cost curve. Everybody's got that down. That's not a problem. Let's see what the marginal cost curve is going to look like. Let's draw that down here. We'll label the axes the same thing, quantity and $. So these two axes right here, these two quantity axes are going to talk to each other. That is to say, every increment along here lines up with every increment here. Now notice up until about this point right here, which would be about this point here on this axis, marginal costs are diminishing. That means that the marginal cost function is going to be going down until it reaches that point, like this. Then the variable cost curve hits this inflection point. The inflection point is the point at which it stops rising at a decreasing rate and starts rising at an increasing rate. That is the rate at which marginal costs are going to start rising, like this. So the marginal cost function will look like that. Will be kind of U-shaped, like that. First rising at a decreasing rate, and at the point at which the variable cost curve hits that inflection point, the marginal cost curve will start rising. The rising marginal cost curve is, and its relationship to the variable cost curve, is illustrated on page 173. Now let's look at the other cost curves that we're going to be dealing with here. That would be the average total and the average variable, as well as the average fixed cost curve. What are these going to look like? The arithmetic for deriving the average variable and average total cost curve is shown in table 8.4 on page 174. You're just going to be taking the total costs and dividing that by Q to get the average total cost curve, the total variable cost, dividing that by Q to get the average variable cost curve, and the two are going to look like this, as it turns out. They're going to be kind of U-shaped like this, There's the average total cost curve, the average variable cost curve. Now, we're not going to need to draw in the average fixed cost curve, because the average fixed cost curve is going to be the difference between the average variable and the average total. So we already have that information. What we need to add here is the marginal cost curve. Now, the marginal cost curve is going to look like this. As you know, it's going to go down, it's going to hit some minimum point, and it's going to start rising. So the marginal cost curve is going to look like this. If you look carefully, although I'm not the best artist in the world, and perhaps I'm the worst, you will notice that the marginal cost curve intersects the average variable cost curve and the average total cost curve at their minimum points. Now, this is a fundamental mathematical relationship that must occur. The marginal cost curve will intersect the average variable and the average total cost curves at their minimum point. Once again, you can check this out on page 174 in the textbook. Here's the reason why. Let's suppose that we go bowling. And the first game that I bowl a 100. It's not too bad for me, actually. Okay, so then somebody says, well, what's your average? Well, to compute my bowling average, I would add up the total pins I have ever knocked down in my life and divide it by the number of games I've played. So in this particular case, it'll be 100 pins divided by one game, so my average is 100. So let's suppose that we bowl another game, and in this second game I bowl an 80. What now is my average? My average is 180 divided by 2, 90. Okay, so my bowling average has gone down. In the next game, let's say I bowl a 60. I must be getting worse. I must be getting tired. So what now is my average? My average is, let's see, 100 plus 80 plus 60. That's 240 divided by the number of games, 3. 240 divided by 3, so my average is now 80. So let's suppose that we decide to bowl one more game, a fourth game, and in this case I get a 120. My average now is, let's see, 240 plus 120, 360, right? Divided by 4 games, my average now is 90. Now, notice this. Notice that when my bowling score, which could be equate to the marginal value, which is the additional amount that's added to the total, when my marginal lies above my, when my marginal lies below my average, it brings the average down. When my average was 100 and the marginal, that is the score of the next game, was 80, it brought my average down to 90. When my average was 90 and the marginal was 60, brought my average down to 80. Notice how when the marginal lies below the average, it brings the average down. However, the next game, when my score was 120, my average was 80, it brought the average back up to 90. When the marginal lied above the average, it brought the average up. In the same way here, when the marginal lies below the average, whether it's rising or falling, when the marginal lies below the average, it's pulling the average down. When the marginal lies above the average, it pulls the average up. When the marginal lies below the average, it's pulling the average down. When the marginal lies above the average, it's pulling the average up. That's a very bad picture. Let me see if I can't draw a little bit better one to illustrate. I'm trying to do it vertically here. Average variable cost, average total cost, Here's what the marginal cost looks like. There's the minimum of the average variable. There's the minimum of the average total. Marginal cost curve is going to look like this. See how it passes through the minimum? Marginal cost. Marginal cost, average total, average variable. We don't need to draw the average fixed. That information is already there. It's the difference between the average variable and the average total. Now there's a couple of more of these little videos we have to talk about, and those are on long-run cost relationships. But this will do you for a little while, okay? Master these, then go on to the long-run cost relationships. That stuff is in Chapter 9. We'll be seeing you soon.